Hello everyone, welcome to Sources classes. So in this video again we'll be continuing our discussion with respect to questions pertaining to the quantitative aptitude section of the paper. So let's take a look. For two positive integers a and b, define the function h of ab as the greatest common factor GCF and ab of ab. Let a be the set of n positive integers g of a. The greatest common factor of the element of set A is computed by repeatedly using the function h. Okay, the minimum number of time h is required to be used to compute g is, so let's see, for two positive integers. So we have two positive integer ab. So positive integers, we have a comma b. Okay, define a function h comma a b, where a is the greatest as the greatest common factor. What we need to find, this is basically HCF of a comma b. Okay, let a be a set of n positive numbers. So suppose we have a set a, so we have n positive integers. Okay, n positive integers. The greatest common factor of the elements of set A is computed by repeatedly using the function h. Okay, so it's repeatedly used by using function h. The minimum number of times h is required to be used to compute g is basically okay. So now let's say g of a we need to find out. So we need to use the function of greatest common element. So we need to find basically the HCF of all elements. Okay, in this regards. Okay, now try and understand something. Suppose I have a set, say 1, 3 and 4. Okay, and now if I am to find suppose this is my set A. Okay, suppose this is my set A, and now if I am to find the greatest common factor, okay, the greatest common factor of this one, so minimum operation that I'd have to perform would be uh, first I'll pick any two, then I'll pick any two, and then I'll pick subsequently I'll pick for any two. So basically what I'll be doing is that I'll be computing the entire thing for there are since 4 terms, so overall 2 to 2 if I take, I'll be computing the same for 3 times. Okay, I need to find the greatest common factor so that I can get the entire thing. Similarly, if I have say 5 elements in the set, I'll be computing the same for 4 times. Okay, and similarly if I have n elements, I'll be computing it for n minus 1 times. I'll give you a very simple example. Suppose A has 1, 2, only 2 elements. Okay, so to perform the operation of HCF, I will only be performing it 1 times. Basically, HCF of 1, 2. Okay, only one performance of the operation would give me this answer. So that's the similar case. That's how we can actually attain. So total n minus 1 time we need to do. So option 2 will be our answer. Okay, pretty the question seemed to be pretty complicated when we went through the entire language of it, but when we tried to solve this question, it turned out to be pretty easy. Okay, so I hope this thing is clear to you. Just keep this particular example in mind. Okay, and you can keep these results in mind as well, so that you can have an idea whenever come across question based on this further down the line, you are easily able to solve the same. Okay, so I hope this explanation is clear to you. Now, having said all of that, if you're looking for a detailed solution of the entire paper, feel free to connect with us, or that you can look us up using the links provided in the description. Also, if you're looking for any kind of guidance or help with respect to your competitive exam preparation, whether you need any kind of help in this regard, feel free to connect with us for that as well. We'll be more than happy to help you out. Also, if you are, actually looking to get some idea or explanation upon any subject, or you need help with respect to any subject or topic on which you feel our expertise are required for your explanation and better understanding, please do get in touch with us for that as well. We'll be happy to help you out in this regards as well. Okay, so having said all of that, if you like the video, make sure you like, share and subscribe to the channel so that we'll keep coming up with relevant content such as this further down the line as well. So with that, I'll be signing out. So thank you so much.